Hello there. You're watching Differential Questions by Alex. All right, so today's topic is going to be reduction of order. All right, so that's the topic, and that's me. Okay, so today we want to focus on second order linear differential equations, which look something like this. Okay, so you have the second derivative to be the highest derivative, and then this is equal to a function g, and you might have functions a, b, and c in front, and the a, b, c could be functions, could be constants, doesn't matter. And so we want to solve this type of equation. And so what we're going to do here first is let me give you the question and then let me give you the method on what we're going to do. All right, so here's the type of equation that we'll deal with. This is a homogeneous because it's a zero. So a homogeneous linear differential equation, second order. And so the catch here is that in order to solve this, we are first going to suppose that we already have one solution, okay? So the problem is going to give you one solution, y1, and then our test is to find the second solution, okay? So find the second solution so that the set is a linearly independent set and also our solutions, okay? So therefore it's called a fundamental set of solutions. All right, so that's the question, that's the problem. You have a differential question and the y1 is given to you and then we need to find the y2. So the technique is the following. So let me write this in blue. We are going to make y2 equal to u times y1. And then the catch is that we do not know what the u function is. And so our goal, we have changed our goal. Instead of finding the y2 function, we're going to be finding the u function. And so in order to do that, we're going to substitute the y2 function into the differential equation, which means that we're going to use this blue box on the bottom, and we're going to use the first derivative, and then we need to use the second derivative. So these three pieces of information are going to be substituted into the differential equation. So because we have the function, the first derivative, and then the second derivative. So once we substitute that, then we are going to do a little bit of algebra and a little bit of calculus to find the u function. And once we find the u function, we automatically find the y2 function. So it's a little bit sneaky, but that's the process. All right, so let me give you a specific example. So again, the differential equation is given to us, and then also one function that is a solution is also given to us. So that's the catch. So now what we need to do is we need to find the y2 function. The question here is asking you to find the general solution of the differential equation. So the general solution is equal to y is equal to c1y1 plus c2y2, but that's assuming that you know y1 and y2. The y1 is given to you, but the y2 is what we're looking for. And so this is the question that we are focusing on. We need to find the y2 function. All right, so what do we do? Okay, so we're going to make the following function. We're going to make y2 equal to u multiplied by y1. And what I'm going to do here is that because it gets clumsy to write down y2 over and over again, so I'm just going to write down y is equal to u, and I'm going to substitute the y1, which is e to the 1/3 x. All right, so we are making this function. Okay, so we make this function. And now that we have this, we're going to need to find the first derivative of this thing. We need the formula for that. And then we also need to find the second derivative of that function. And so we have these three pieces of information that we're going to substitute into the problem, into the differential equation, into the y prime, and into the y double prime. And then we're going to make it equal to 0. And then our goal is to find what the u is equal to. Again, that is the goal at the moment. So it gets a little clumsy to write this down by hand. So what I've done is I've typed it up for you. And so here's the y function that we made. This is the y function, and then this is the u times the e to the 1/3 x. The y prime, after you do the product rule, and you have to do the product rule. So let me just kind of summarize here. So this is the first function multiplied by the derivative of the second one, plus the second function times the derivative of the first function. So that's the product rule, and so that's how we get the y prime. Now we have to find the y double prime. It gets lengthy, and so you have to do product rule twice. Here's the first product rule, and then here's the second product rule. Okay, so let me just underline that in a different color. So this is the first term, and then this is the second term, and so that's what I've underlined here because we have to define the product rule twice. All right, so now we do a little bit of algebra, not difficult algebra. You combine the like terms, which in this case, you combine the stuff that have the u prime together, and you kind of move things around a little bit. And so we have y double prime to be this guy at the very end. Right, so we have the y function, the y prime, and then the y double prime, and then we are going to substitute those three pieces of information into the differential equation, into the y prime, and into the y double prime, and then we're going to make this equal to 0. So what I've done, because it gets a little tricky when you write this down on board, on a very small board, and so what I've done is the following. So the original y function, I multiply by y, okay? And then the original y prime function, I don't have to do anything, it's just plus y. And then the second derivative, I multiply by 6. So I multiply by 6 everywhere on my equation that I had previously. Okay, so that's how I get those three lines in the beginning. And so whatever you do on the left side of the equation, you have to do that to the other side of the equation. So that's why I have these three lines. All right, so now what we're going to do here, first of all, let's simplify the equation with the 6y double prime to be this. As you simplify the numbers, you get this thing. So what we're going to do is we're going to add these three red lines. Okay, so if you add the left side, of the equal signs, these three things, then you end up with this part. Okay, and then we do that because we want to match the differential equation. So adding the left side of those three lines gives you the differential equation, the left side of the differential equation, and then adding the right side of those three red boxes will give you the following. Okay, so let me put that in a very bright color. So we have to combine this green stuff. Okay, so this green stuff we combine, and then if you do the calculus, the algebra, then you will end up with this thing on the very bottom. Okay, and the first term is a 0. Okay, so this actually turns out to be 0. 0 times anything will give you 0. So that's actually a good thing. All right, so what we have done is the following. We have said that this blue box that we have as a differential equation, this turns out to be the green information that we have. So this is a 5e to the 1/3 x multiplied by u prime plus 6e to the 1/3 x u double prime. And what we're going to do is we're going to make this equal to 0. Okay, so we're going to make this equal to 0 because we are substituting things into the differential equation. All right, so we have this differential equation, and it seems like we haven't done much at all. So what we're going to do is we're going to rewrite this a little bit. Okay, so let me write down the double prime first. Actually, let me do one step ahead of the game. So divide everywhere by 1/3 by e to the 1/3 x. Divide everywhere by this guy, and you can do this because this is the exponential function, and so you are allowed to divide by this guy. And so when you do that, you end up with the following. Okay, so you have 5u prime plus 6u double prime is equal to 0. And we usually write down the double prime first. And so we get this. So 6u double prime plus 5u prime is equal to 0. So this is a 6 here. And also we want to get the u double prime just by itself. And so we are going to write this down as follows. So we're going to get u double prime plus 5 over 6 u prime is equal to 0. All right, so that's the equation that I get here. So that is the equation that we have now. So a little bit lengthy, and the problems will get lengthy as we go with the class. But remember what the question is. We have a differential equation, and then the y1 function was given to us. And the y1 function was given to us, and then our goal is to find the y2 function. And so in order to find the y2 function, we make the y2 is equal to u multiplied by y1. So we make this substitution into the differential equation. We technically find the first derivative, second derivative, plug that information into the differential equation, and then we get this green line on the very top on the right side. All right, and then we kind of simplify the whatever we can, and so we now have this black box on the bottom. All right, so we have a differential equation, but this differential equation it is still a second order differential equation, and but it's a little bit nicer. Okay, it's a little bit nicer, and then it's nice because of the following information. So I just rewrote the equation that we had, and so now what we're going to do here is we're going to make another substitution. Okay, so we let w is equal to u prime. Okay, so this is the second part of the method. Okay, so this is method one, but this is the second part of the method. The first part was make y2 is equal to u times y1. The second part of the method is let w equal to the u double prime. Sorry, let w be equal to u prime. If that is the case, then the w prime is going to be equal to u double prime. And what we're going to do is we're going to substitute these two pieces of information into the equation. Okay. And so when we do that, then we get the following. So this becomes w prime plus 5 over 6 w is equal to 0. Okay. All right, so now this is a good thing for us. You have to realize that this is a first order linear differential equation. Okay, this is a first order linear differential equation. So that is the tricky part. We started with a second order differential equation. We do two substitutions, and we now have a first order differential equation. And first order differential equation is what we covered in the previous chapter. So there's two ways to solve this problem. One way is by using the integrating factor. Okay, so one way to solve this gray equation is by the integrating factor. The other way is actually more easy, and that's by the separation of variables. Remember that actually was the first method that we learned. Okay, so I'm just going to rewrite it this way, that way you can see that we can do a separation of variables. And so that means that we want to get the w's and the x's by themselves separately. So let me just show the steps briefly. So we have negative 5, 6, w, and then the last step would be 1 over w. The w is equal to negative 5, 6 dx. Okay. All right, so now we have separated the variables, and so that means that we can integrate. Okay. The next step is to integrate both sides. Okay, but we have to be careful that we're going to integrate with respect to w on the left side and integrate with respect to x on the right side. And so when we do this, let's go back in this way, and so we'll get ln of w is equal to negative 5, 6x, and then plus a constant. Okay, plus a constant. All right. So now this is ln of w, but now we want to get the w by itself, so we're going to exponentiate both sides. And so it's going to be e raised to that side and e raised to this guy. And so when we do that, we're going to get the w is equal to, let me write it out this way, so just to show the steps, e raised to negative 5, 6x multiplied by e raised to the c. Okay. And now here just a quick reminder. So c is a number that we don't know, and so e raised to the number that we don't know, it is still a number that we don't know. So we technically just write down c again. Okay, e raised to the c, we are just going to rewrite it as c because c is just a number that we don't know. And so finally, we are going to rewrite this as c e raised to the negative 5, 6 x. Right. So that's our formula for w. But were we looking for the w function? Were we looking for the w function? No. Initially, we were looking for the y2 function. So let me remind you. Initially, we were looking for the y2 function. So that was the original question. But then we changed the question, and then we were looking for the u function. But here we have the w function. So we kind of have to go back now. We did two substitutions, and so now we have to resubstitute twice. So let me write down the w function and then the other piece of information that we have. Okay, so the w function is given by this, and then we have to remember that we made the substitution w is equal to u prime. So we're going to resubstitute w, and so this is going to be u prime is equal to c e negative 5, 6 x. And so if this is the derivative, then all we have to do now is we integrate to get to the u function. All right, so let's integrate this. So this is going to be c e raised to the negative 5, 6 x technically divided by negative 5, 6, and then plus another constant. Let me call that constant C2. All right, so now here is another place where we have to play around with the constants. So C is a constant that we don't know. So C divided by negative 5, 6 is still a number that we don't know. So what we're going to do is we're just going to relabel this as C1e raised to the negative 5, 6x plus C2. All right, so that is our u function. And were we looking for the u function? Yes, technically yes. But remember, we made the y2 is equal to u multiplied by y1, and at that point our goal was to find the u formula. And so now we have the formula for the u function, but we have to remember that our ultimate goal was to find the y2 function. Okay, so that's what I'm going to do on my next slide. Okay, so we have the u function, and we have to recall that we initially were looking for the y2 function, and the y2 function is u multiplied by the y1. The y1 was given to us. Okay, so this y1 was given to us from the problem, and we needed to find the u, which we did. Okay, so it's up here, and so now we substitute things in here. And so y2 is going to be equal to, this is the u function, so c1e raised to the negative 5, 6x plus c2, and then multiplied by the y1 function, which is e to the 1/3 x. All right, so we can distribute here a little bit. So this is going to be c, and when you distribute, okay, so let me just show one step here. So negative 5, 6 x multiplied by e to the 1/3 x plus c2 e to the 1/3 x. All right, so this is a 5, 6 here. So when you have the same base but different powers, then you can add the powers. So this becomes C1, and so that would be negative 5, 6 plus 2. So it should be e to the negative 1/2 x. So the common denominator is 6. So multiply the 1/3 by 2 top and bottom. So you get a 2 over 6. So negative 5 plus 2 is negative 3. Negative 3 over 6 is negative 1/2. So C2e to the 1/3. Okay, so this is actually the answer to the problem that we had. So I'm going to say 2 comments here. So we're done with the question, but we have to interpret the information. The original question was asking you, what is the general solution to the differential equation? So we want to kind of delete this y2. This is the general solution, because this is a linear combination. But if you're looking for the y2 function, you are going to make a specific choice. Okay, so you're going to make c1 is equal to 1 and c2 is equal to 0. And why do we make c2 is equal to 0? The reason we make c2 equal to 0 is because this red function that we have next to the c2, that is the original function that was given to us. So we want to kind of delete that away, and then that's how we get the y2 function. And so we get e raised to the negative 1/2 x. So that's the y2 function. All right, so a little bit of a process here, but it's not super complicated. It's just lengthy. Okay? But just gonna keep track of the steps. We have 2 substitutions, and then we have to resubstitute back. The first substitution was we changed the problem from looking for the y2, and then we changed the problem to be looking for the u function. Then we changed the problem so that we were looking for the w function. But then we have to kind of resubstitute twice to get back to the y2 function. And then here at the very end, I do call it y2, but technically we are getting the general solution first. Okay, we first find the general solution to the problem, and then I make the extra step to find the y2. And then you might be thinking, why do we choose specifically c1 is equal to 1 and c2 is equal to 0? You are free to choose these 2 numbers however you want to. If you want to choose 1 and 2 or 3 and 5 or whatever numbers, you're free to do that. Okay. But the reason that I chose C2 to be equal to 0 is because I want to delete my y1 function. And then I made the C1 equal to 1 because I want to have just the function without any extra numbers here on my y2 formula. All right, so that's the first method. Okay. So now we're going to repeat the story. Actually, we're going to repeat the question, but we're going to use a different method to solve this type of problem. And most people like the second method because it's a formula, but we have to be comfortable with both. So the second way to solve the problem is that you have the same problem, and so you have a differential equation, and then you want to find the second solution. So the first solution is given to you, but you want to find the second solution, and here is the formula. Okay, so here is the formula to find the second solution, but there is a catch. The catch is that your differential equation has to be on a specific format. It is a second order linear homogeneous differential equation. It is homogeneous, it is linear as before, but the catch is that it has to be in the standard form. And standard form, roughly speaking, it just means that the y double prime does not have anything in front of it. Okay, so there's like a 1 here, technically. So that's the catch. If you want to use this formula, you have to put the differential equation into the standard form. If you have the standard form, the only thing you need to identify is the p function. That is what goes into the formula. And some people will ask, what about the q function? There's a little bit of a catch. So remember that the y1 function is given to you, right? So in this type of problem, the y1 function is given to you, and so the q is kind of like inside of the y1. I'm not saying that the q formula is inside the y1 formula. I'm saying that in this formula, you don't see the q function because the q kind of affects the first solution. Okay? It affects the first solution. So, but in the formula, you never do see the q function. But the catch is that you have to put in to the standard form. So let's go with a specific form if I repeat the same thing over and over again. All right, so we have the same problem. So we have a differential equation. Let me put this in blue. So we have a second order linear differential equation, and a function is given to you that is a solution to the problem. Okay, so the y1 is given to us, and then this is a solution to the differential equation. And the equation is the same as before. We want to find the general solution to the differential equation. So in order to find the general solution, we need to find the y2. Okay. So what we're going to do is we use the formula. Okay. So we use the formula. But again, in order to use the formula in this case, we need to put the differential equation into the standard form. The equation that we have is not in standard form because the y double prime has an x squared in front of it. Right? So what do we need to do? We need to divide everywhere by x squared. Divide by everywhere by x squared. And so we'll get the following equation. We'll get y double prime minus, and then this turns out to be negative 7 over x y prime plus 16 over x squared y is equal to 0. Okay, so let me just double check my calculation for the p function. So 7x divided by x squared, that gives us a negative 7 over x. All right, so here we need to identify the p function. Okay, the p function is negative 7 over x. Okay, so now that we have this, we can integrate this. Okay, so we need to find the negative, the integral of the p function. So I'm doing this step by step. And so this becomes integral of positive 7 over x. The negatives cancel out. So just double check. You can see that this cancels out. So this gives you 7 ln of x. Okay. So that's the negative integral of p dx. But in the formula, we have this e raised to the negative integral of the p dx. And so this becomes e raised to the 7 ln of x, which is e ln of x to the 7, which this simplifies to x to the 7 power. So a little bit of algebra with the ln and the e. So that is some algebra that we have to review. But now we have figured out what this quantity is. Okay? So now we are ready to use the formula that we have. Okay, so the first part is to identify the p function, and then you do need to be careful with finding this e function, e raised to the negative integral p dx. So do it step by step. That way you don't mess up on the calculation, because this is one place where people mess up all the time. All right, so let me just repeat the information that we have. We calculated this e raised to the negative integral p dx, and then we also have to remember that we have a y1 function. Okay, so that means that we now can use the formula. Okay, so formula is given to you here, and so we are just going to substitute. So y2 is going to be y1, which is x to the 4 integral of this e stuff. So this turned out to be x to the 7 divided by y1 square. And so let me just write down this in detail. So this is x to the 4 square dx. So we need to simplify this. And here is one point where I need to emphasize that the x to the 4 is outside the integral. You cannot push it inside. And also you cannot push out the x to the 7 outside the integral. You cannot move functions. Numbers you can. If you had just a number, then you can push it in, push it out, the integral. But here we cannot do anything with the x to the 4. And so let's simplify the integral. The integral inside becomes x to the 7 divided by x to the 8 dx. And then that is the same thing as 1 over x. And so that becomes ln of x after you integrate. All right, so that is the y2 function. All right, so were we looking for the y2 function? In a way, yes. The original question is asking you to find the general solution. So you have to kind of make sure you know the terminology. The y2 is the second solution to the differential question. And so now, in order to answer the question about the general solution, we are going to make the linear combination of the y1 and then the c2. So that's going to be the general solution. And so the general solution is going to be c1 multiplied by the y1, which is x to the 4, plus c2 multiplied by the y2, which is x to the 4, ln of x. All right, so that is your general solution. So this is the general solution to the given differential question. All right, so the second method is much easier, but again, you have to make sure that your differential question is in the standard form, so that way you can identify the p function, because the p function is very, very important. If you choose the wrong p, then you're solving a very different problem. And again, the q function does not appear in the formula because the q function is actually affects what the y1 answer is. So you actually never see how the q function is involved here, but just know that it's like behind the y1 function. I won't tell you here why, but that's the idea. So you do the process, and then you get the second solution to the differential question. And so the y1 comma y2, this is going to be a fundamental set of solutions. And once you know that you have a fundamental set of solutions, then you can write down the general solution, which is the linear combination. All right, so that's it for this. I hope that this is helpful, and I hope that the step-by-step is clear. I'll see you next time.